Today I am going to talk about VLAN. What is VLAN? VLAN stands for Virtual LAN. What is Virtual LAN? When we logically divide one physical box, that is switch, into two or more different LANs. This is called as VLAN. For better understanding the concept of VLAN, let us consider this topology in which there are two switch 1 and switch 2. Here, switch 1 having 3 ports P1, P2 and P3. So, switch 1's port P1 is connected to the PC1 having MAC address A and IP address 10.0.0.1/8, and port P2 of a switch 1 is connected to PC2 having IP address 10.0.0.2/8 and MAC address B, and port P3 of a switch 1 is connected to the PC3 having MAC address C and IP address 10.0.0.3/8. Now we have another switch called as switch 2. It has three port P1, P5 and P6. Port P1 of a switch 2 is connected to the PC4 having MAC address D and IP address 20.0.0.1/8, and the port P5 of a switch 2 is connected to the PC5 having MAC address E and IP address 20.0.0.2/8, and port P6 of a switch 2 is connected to the PC6 having MAC address F and IP address 20.0.0.3/8. Initially, the MAC address table of both the switches are empty. The MAC address table has a two field, one is MAC and another is port. Also here, this is a MAC address table of switch 2 having two field, one is MAC address, second is port. Now consider a first scenario where PC1 wants to communicate with PC2. It creates Ethernet frame having a few fields. First, it contains destination MAC, second, source match, third, type field, fourth, data field, and fifth and last field is FCS. This is called as frame check sequence. Okay, it creates a frame. Destination MAC is B, source MAC is A, type is type field, data field, and another one last is FCS. It is called as frame check sequence. Now this frame has been transferred to the wire by PC1. Now switch 1 will receive that frame at port P1. Now the functioning of a switch. We know that functioning of a switch. First, it will check the source MAC address of the frame, which is A, in its MAC address table. Now here not present, so it learn the MAC address A at port P1. A at port P1. Now second step. Switch 1 will check a destination MAC address of a frame, which is B, now present in its MAC address table. So it will normally flood the frame, flood towards a PC3 through port P3 and PC2 through port P2. Now we will assume that the PC3 will receive that frame. First, it will check the destination MAC address of the frame, which is B, and it compares in its own MAC address, which is C. There is no match, so it will simply reject that frame. Similarly, the PC2 receive that frame and it will check the destination MAC address frame, in this case which is B, and now it will compare in its own MAC address which is B. So here match, so the frame will accept at PC2. Now this concept is also applicable for that switch also. Consider another scenario where PC4 wants to communicate with PC5. It creates a Ethernet frame having destination MAC address E, source MAC address D, type field data NFCs. E, D, type data NFCs. Now it will transfer that frame towards the switch 2 at P4. Now switch will receive that frame at port P4. Now what will we do? The functioning of switch, it will check the source MAC address of the frame D and compare in its MAC address table. Here a MAC address table of a switch 2 is empty, so it learn the MAC address D at port P4. D at port P4. Okay, and now second step, it check the destination MAC address of a frame, in this case which is E. It does not present in its MAC address table, so it flood the frame towards PC6 and PC5. Now let us assume that first PC6 will receive that frame. It check the destination MAC address of a frame is E, compare its own MAC address which is F, does not match, so it simply rejects that frame. And now the PC5 will receive that frame. It will check the destination MAC address of the frame which is E and comparing its own MAC address which is also E, matches, so it will accept that frame. Now this is the functioning of a switch. Now we have a luxury, so we had two different switches. If we don't have a luxury, then we have only one switch. Now how these topologies work on one switch? Now let us discuss. I will combine these two switches into only one switch. MAC address from the switch 2 is not present, so we'll remove that frame. Now here consider the same example. When PC1 wants to communicate with PC2, it creates a Ethernet frame having destination MAC address D, source MAC address A, type data bit NFCs. This frame will transfer to the wire. This is P1 switch, port P1 will receive that frame. Now functioning of a switch is remains same. It will check the destination, the source MAC address of a frame, initially the empty, because we will create add a new switch here. So MAC address entry is empty here. MAC address table is empty here. Now it will check source MAC address A in its MAC address table. It is not present, so learn A at port P1. And now second step, it check the destination MAC address B in its MAC address table. Here not present, so it normally flood the frame to all of its ports. It flood the frame towards PC3 through port P3, towards PC2 to port P2 towards PC6 through port P6 towards PC5 through port P5 and towards PC4 through port P4. Okay, now PC2 will receive that frame. It checks the destination MAC address of frame which is being compared in its own MAC address, which is also being here matches, so it will accept. Fine, good. But problems may occur here. When this frame of a 10 network is reaches to PC4, 5 and 6. For this PC, this is the disturbance or noise. Why? Because these PCs are in 20 network and these PCs are in 10 network. There is no communication between 10 and 20 network. So this information of flooding the frame is noise and disturbance for all of these PCs. Now we have to find a way to create a different LAN within a single switch S1. So we have a new concept. This is called VLAN. Now with the help of VLAN, we divide a single switch, that is switch 1, into two different LAN. Now with VLAN 10 and VLAN 20. Now I simply divide this switch into two LANs. This is VLAN 10 and this is VLAN 20. Now the two more concepts or topic are increased due to the VLAN. First is access port and second is trunk port. And now what is access port? Access port are those ports when it receives the frame, it adds a VLAN tag, and when it sends the frame, it will remove the VLAN tag. How it is possible? Now, and another part of definition of access port is a dedicated port to particular VLAN. A access port can never be a part of two VLANs simultaneously. Okay? Now I discuss how the communication between the VLAN 10 and VLAN 20 has been performed in this scenario. First, I will discuss the communication of PC1 and PC2 within the VLAN 10. Okay, initially the switch 1 having MAC address is empty. When we divide the one switch into two or more different LANs, VLANs, then another field is added to the MAC address table. That field is called as VLAN tag. A VLAN tag is of 4 bytes. Now, consider a case where a PC1 wants to communicate with PC2. Now, it will create a Ethernet packet having the destination MAC address B, source MAC address A, type, data and F6. Now, this frame has been transferred to the wire. Now, switch 1 will receive that frame at port P1. Now, the port P1, P2, P3 and P4, P5 and P6 are access port. Port P1 is in VLAN 10, port P2 is in VLAN 10, port P3 is in VLAN 10, and we will configure that port P1, P2, P3 in VLAN 10. So, the PC1 is also in VLAN 10, PC2 is also in VLAN 10 and PC3 is also in VLAN 10. Similarly, we configure that port P4, P5 and P6 in VLAN 20. So, PC4, PC5 and PC6 are all in VLAN 20. So now we are here at port P1. It receives that frame. This is the access port, so it will add the VLAN tag. VLAN tag is of 4 byte. Now how will it add the VLAN tag? First, destination MAC address. Second, source MAC. Third field is VLAN tag of 4 byte. Now type field and data field and FCS. Now the frame will changes to DMAC, B, source MAC, A, VLAN tag 10 because this port in VLAN 10. Type field, data field and FCS. Frame check sequence. Now this frame or VLAN tag has a locally significant with a VLAN or within a switch. As soon as the frame is removed or sent through the access port, the VLAN tag has been removed. Now the port pin will receive this frame. The functioning of a switch will remain same. It will first check a source MAC address of a frame, which is A, compare in its own MAC address table. Here initially it is empty, so it learns the MAC address A at port P1. And here the port P1 is in VLAN 10, so it will add a VLAN tag as 10. Okay. Now second part of the definition of switch or functioning of the switch, it check the destination MAC address of a frame, which is B, and compare in its own MAC address table. Here the entry of B is not present in its MAC address table, so it flood the frame to all port within a VLAN because this is a single VLAN, VLAN 10. So the switch will flood the frame at port P3 and P2 only because these two are in VLAN 10, and port P1, which learns the MAC address is also in VLAN, so it will just flood the frame in VLAN 10 only, but not at a port P4, P5 and P6 because they are in another VLAN. They are in VLAN 20. Okay. Now initially, if we assume that the PC3 will receive that frame and it checks the destination MAC address of a frame, okay, which is B, and compare in its own MAC address, which is C, does not match, rejects. Okay, simply reject. But before the frame is reaching at PC3, the port P3 will came here. The port P3 is access port, so it will remove the VLAN tag. So the PC will receive that frame without VLAN tag, only destination MAC, source MAC, type, data and FCS. Similarly, the frame is sent out through the port P2, it also removes the VLAN tag. Now PC2 will take this frame with destination MAC, source MAC, type, data and FCS. Now PC2 will check the destination MAC address of a frame, which is B. Now it compares in its own MAC address, which is B. So here matches. Now it will accept that frame. Now this is a case or this is a scenario where PC1 communicate with PC2 within a single VLAN, which is called VLAN 10. Okay. Now consider a second scenario where PC4 wants to communicate with PC5. It will create a Ethernet frame having DMAC or destination MAC is E and source MAC is D, the type data and FCS. Now, this frame is transferred to the wire which will receive frame at port P4. Now it will add the VLAN tag because this is access port. It will add the VLAN tag 20 because the port P4 is in VLAN 20. We configured that port in VLAN 20. ED20 type data and access. Now PC switch 1 will receive that frame at port port P4. So it will check first destination. It will check first source MAC address of a frame. D, compare in its MAC address table. So here it does not form the entry regarding D. So it learn MAC address D at port P4 and VLAN 20 because the port P4 is in VLAN 20. Now this second step, switch will check destination MAC address of a frame which is E and it checks in its MAC address table. The entry of E is not present in its MAC address table, so it will flood the frame. But flood here only the ports which is present in VLAN 20 because it learns the MAC address D at port P4 at VLAN 20. Flood here and flood here. Let us assume that PC6 will receive that frame and check the destination MAC address of a frame before the PC6 will receive that frame. The port P6 has received that frame. Port P6 is a access port, so it will remove the VLAN tag. Now PC6 will receive that frame with destination MAC, S MAC, type data and FCS. Now PC6 will check the destination MAC address of the frame which is E, compare in its own MAC address which is F. Does not match, so it will simply reject the frame. Now switch 1 will receive send the frame through port P5 which is access port, so it will also remove the VLAN tag, and PC5 will receive that frame with DMAC, SMAC, type data and FCS. And so it checks the destination MAC address of a frame which is E, comparing its own MAC address which is E. Here matches, so it will accept that frame. Okay. In this way, the communication between the two VLANs within its VLAN has been established. Communication between PC1 to PC2 is in VLAN 10. The PC1 does not send a flooding message to this LAN, and communication between PC4 to PC5 is in only VLAN 20. The flooding message does not go to the VLAN 10. This is only achieved by the virtual LAN, VLAN.